Hello everyone, welcome back to lecture number 4. This time we are still talking about knowledge graphs. I will give you a quick review on some of the topics we talked about last time. I will also, again, very quickly talk about another vocabulary language that we don't cover in so much detail in this course called OWL. And then we'll come into the main topic for today, which is how to query a knowledge graph. So far you learned what knowledge graphs are, how to create knowledge graphs using triples, and last time we talked about the importance of vocabulary languages. So the main point was that when we write data using triples by themselves, these URIs don't really provide any semantics. You don't know if you have a URI for Concordia University, what Concordia really is. Is it a person? Is it something to eat? Is it a movie? You need to have some agreement on how to describe data. Now, if you want to do this on a large scale and enable systems to integrate knowledge from different sources, then you have to have some kind of shared agreement on that. So you want to have a common understanding about common terms like persons, books, authors, and so on. And as a second step, you also want to be able to explain the relationships between them. So how are authors and persons related, and how are books and authors related? And this is done with a vocabulary language. I mentioned that this is also called ontology or schema, depending a bit on the domain you're coming from. But essentially, this is a language that enables you to define these vocabularies. And the goal is to give a clear semantics on the description of the data that we have. So if you think of traditional vocabularies, you have kind of a shared understanding of something like a book, a novel, of hierarchies between the terms, that every novel is a fiction, and of instance relationships, like we looked at the book The Glass Palace, and this is of type novel. And one language for defining these kind of vocabularies using the web standards that we talked about is RDFS, the RDF schema. So this is what we covered last time in detail, how to define a class, how to define subclasses and class instances and so on. So again, one of the interesting things is that this is again defined using triples. So both the data is a triple and the vocabulary about the data is a triple. And that's quite elegant because if you have a large collection of triples and you want to understand it, you can just add the triples that is coming from the vocabulary from RDFS to it and use it to interpret the data. So there is no separate distinction between, like in programming, classes and objects. Dynamically, you can create more RDFS concepts and use them for reasoning, linking, understanding data. So last time we looked in detail how this works, how to define something like a class, how to define a subclass, and how to define an instance using RDFS, which in turn writes these definitions using RDF triples. So we've seen this, for example, for an instance of a specific class and for defining a class. To make sure you remember how this is done, since it's been a week, there is another worksheet, and the first 2 tasks on this worksheet are a quick refresher on how to define classes and instances. So the first 2 tasks on worksheet number 3, just write a few triples according to the specification here, and then answer the question below. And when you're done, I will see you in the next lecture part.